Guys, today we'll learn how to measure the tetracycline dye. So you can see the brand here is Rich. Now the first task is to prepare the stock solution. We'll weigh around 100 milligram. To be on the safe side, I'm taking around 150 milligram, around 150 milligram. So I'll remove a pinch of it. Then I will add to the Olympic flask, or you can say the conical flask. The second task is to transfer the deionized water. So I'll add around 1 liter of the deionized water. This 500 ml. Then again I would add another 500 ml. Transfer around 1 liter of the water. I will shake it overnight so that the mixture is homogeneous, and also I'll heat a bit so that it dissolves faster. Now also I have covered this so as to avoid any kind of light, or you can say any kind of photo activity, so as to avoid. So just I've covered it. We'll meet after some time or some hours to do the calibration. Now the next step is we have dissolved the tetracycline in the water. So this is sparingly soluble in water. So usually the solubility is 400 to 500 milligrams per liter in the water. Now I have done the serial dilution using the serial dilution concept. C1V1 is equal to C2V2. So we have seen the use of UV visible spectrophotometer and the other concepts in our previously shooted videos. Now we will just first of all scan the tetracycline. We'll use the higher concentration and then we will find out the maximum wavelength. We will press the single wavelength and then we will add our cuvette here. This is our cuvette. Make sure there is no thumb impression. We'll add a cuvette here, and then we need to come out. Have to first of all not do the single wavelength. We'll do the wavelength scanning. Now we'll first press 0. We forgot to reset the wavelength, so we have to reset the wavelength here. That is to be around 200. And then here we will choose around 400. And then we'll zero it again. This is the straight line. Now we would scan the higher concentration. So this is around 110 ppm. So you can see the peaks coming. Now we need to know the maximum wavelength, which is close to 400 nanometers. So it would be, in the literature, is around 350, 360. So it's close to, you can see it's 355. If we press our cursor here, it's close to 359 nanometers as reported by some of the researchers. We'll select 359 nanometers, or we can also select 360 nanometers. I'm going to override the calibration here. This is my DRC. I will select program option, and then I will select edit, and I will select the calibration here. Okay. Say read standards, and then we have some standards already done here. So we'll just say we're going to delete this, all the values. Then I would add. So I would add 0. Sorry, add 1 first. 1. Then we have 5. Then we have 10. Then we have 25. Then we have 50. Then we have 75. And then we have 100. Maximum we are going to 100. Let's start with 0. Now we'll start with 1. Password 1, and then we read 1. So 1 reads 0.032. Then 5. Now we are reading 5. Read 10. It's almost 2 times. We are reading 25, 50, 75, 100. There is a mistake here. We'll try to rectify this. If I selecting this value, let us see the R square of it. It's coming a bit weird. We'll go back and delete this value. Now this is perfectly okay. Now we'll just save done and then store. Data is stored here, and then we can exit. Then we can again say read 0 first. We are just reading the value 0 first. ppm value of 1 ppm is around 0.77. We saw that by changing the wavelength the values are not changing much, so we'll just check at random 5 ppm, not much deviation, so we'll check 10. Done with the measurement of all the standards. We replicated them. You can see here the fit is perfectly okay. Just save it and done. Store, and also we change the wavelength. Now we would just try to measure again. This is our 0. Now we are trying to measure 100 ppm. Sorry, this is 75 ppm, so it's 78.90. 100 ppm. So the 100 ppm shows 100.06, which is perfectly in coherence with the calibration that we created for the tetracycline. That's all for the tetracycline.